I come from an amateur radio or ham radio background. So for me, using radio is something that I really like to do. And what we have found out is the combination of software-defined radio and Raspberry Pi goes a long way in doing a lot of projects. So this is what a software-defined radio looks like. This is from Noilet. And this is a very simple SDR, comes for about $20, available everywhere and used only for receiving data. So basically this is called RTL-SDR. This is a software-defined radio, and this particular one that I am using works from 25 megahertz to 1.3 gigahertz. Now you can use an op tuner to allow it to go through much more frequency range, but we'll just stick to using this. Besides this, we have also used the SDR to capture data from NOAA satellites for weather-related data, and then other signals like air traffic control signals, and then the automatic signal that is transmitted by all airplanes when they are flying over us. So we can use this to capture those kind of data. And since it's working from 25 to 1.3 gigahertz, it works through all HF, VHF, UHF frequencies. So if you connect it to a proper antenna, you could also hear people talking throughout the world using ham radio bands. And you can also listen to people on VHF and UHF. One of the most common ways to use this is to try and hear signals from the International Space Station, where the uplink is in VHF band and downlink is in UHF band. So this is a very simple device. If you open it, it goes into the USB port of the Raspberry Pi. So you just connect to the USB port. This SDR already comes with an antenna, this kind of a whip antenna, which is a general purpose antenna that you can use for many different signals. It's not very good to receive signals from satellites and so on and so forth, but for starting out with an SDR, this is a very good antenna that you can use. So all you need to do is connect this portion to this part, and now this antenna is set up. In our case, to get signal from the NOAA satellites, we have used this Yagi antenna, the design of which we will show in a later video to make this exactly as it is. You will see that this is the connection that goes into the SDR. These are just aluminium pipes that we have to connect, that we have to cut to certain lengths that need to be fitted properly. Again, in another video we'll be showing. And this plastic holding case is made using 3D printing, so this pipes are very sturdy and located at exact distances that we require. So this kind of antenna are extremely simple to make, that you can build at home and you can use it to get a lot of signals. This is for VHF and UHF band, so you can get all sorts of signals that are associated with the UHF and VHF band. A project where we use the Raspberry Pi is to do with collection of data using an accurate 5-in-1 weather station. The weather station gave its data in 433 megahertz frequency, and then we had to capture that data and store it somewhere. So what we did was, using the 433 megahertz frequency, we were able to take the data using a software-defined radio and then store it on a Raspberry Pi so that it can be forwarded later on. All we did was put on this device, allowed it to transmit signals. This transmitted signals every 15 seconds in 433 megahertz. We captured that data using SDR, converted it into data that we could store into text data, and then stored it on the Raspberry Pi.